Okay, so welcome everyone. Today I'll be talking about the differences between the two major technologies in digital radiography, computed radiography and digital detector arrays, or DDA, as we usually call them. But before I get into that, I will do the obligatory information about who we are. So NDT, we're a German company based in southern Germany. We do digital radiography. We have dealers all around the world. Our software development is actually largely done in Malaysia. That's where I am. And we do in-house R&D for a lot of our products. And yeah, we've been around for nearly 2 decades now, but we are actually a subsidiary of a bigger company which has been around for a lot longer, Dental. Yeah, and these are the products we do. So everything to do with digital radiography. So we do the, of course, computer radiography, the scanners, the imaging plates to go with them. We also do direct radiography, so the flat panel detectors, or DDAs as I called them before. And of course, because these are digital, we do the software to go with these two digital products. We also do some of the traditional film radiography. We have a small desktop film processor. We sell some green chemistry as well. But today we'll be talking about these two technologies, so CR and flat panel detectors, or DDA. If you do have questions, just make a note of the slide number in the bottom right corner, and there's a Q&A section. You can just mention the slide number and ask your question, and I'll try and answer it at the end. Okay, so first of all, the two technologies, as I've just mentioned, we have CR, which uses flexible imaging plates in combination with a scanner. You must have a scanner to read these plates. And then we have DDA, or flat panel detector, which is a single device, rigid, requires power. So they're the two technologies we use in digital radiography. And these technologies have been around for quite a while. They've been used in the medical industry for quite a while now, but slowly but surely NDT is catching up, and they're becoming quite popular as a replacement for film. So first one, CR. So CR uses imaging plates. You need a scanner. The imaging plate is reusable, and there's not much, if you're coming from conventional film, there's not much you need to change. You just basically need to swap your film with the imaging plate, and then you obviously need a scanner. But my point is, all the techniques that you use with film are applicable for CR. So you don't need to relearn the fundamentals of radiography. You're just more or less replacing the film with an imaging plate. Of course, the evaluation is a lot different, but technique-wise, it's very, very similar. Okay, the other one, DDA, they're rigid. You can't bend them, and there's no processing step. So let me just go back one. We had this step 2 here where we actually scan the plate. So with a DDA, you get the image more or less live. So it is quicker to get an image. So because it's rigid, there are a few more considerations when you're doing a shot. It needs power, it needs communication. So you may need to run cabling, or think about wireless transmission and things like that. But also, I think it's very easy to move from film to DDA as well. So before I continue, some important terms that I think I should mention before we get into it. So SNR, signal to noise ratio, more or less, you could think of it like contrast, which we talk about in traditional radiography. SRB, which is basic spatial resolution. It's the smallest detail you can see in an image. So these two terms are used a lot in digital radiography. And if you read any of the major standards, for example, ISO 17636-2, they mention these two terms a lot. So they're very important to know. And I keep saying DDA a lot, and DDA is digital detector array, but a lot of people just call them a flat panel detector. So, okay. So I've kind of already said this, but there's the two detector types, imaging plate and DDA. So we call them detectors, and basically they are very different as detectors. Imaging plates come in a lot of different types, a lot of different sensitivities, and different types have different basic spatial resolution capabilities. So you'll find if you see blue imaging plates, they're usually higher resolution, but they require a lot more dose, so a lot more exposure time. And imaging plates can be cut. They come in nearly any size or shape you can think of. And the basic spatial resolution you can get out of them depends, as I just said, on the type of the IP and largely on the laser spot you use when you're scanning. I think I'll probably talk about that a little bit more later, but that's just a quick intro to an imaging plate. DDA, they come in a range of different dimensions, some common sizes, 14 by 17 inch, 17 by 17 inch, 24 by 30 centimeters. These are some of the sizes we offer. And like imaging plates, the material on top, the scintillator, comes in different sensitivities. So you need to choose it based on your application, the scintillator. If you're using isotopes, you choose a more sensitive scintillator typically. And the SRB you can get out of these DDAs depends on largely the pixel pitch and the scintillator. So this one here is our DRC 2430, and that has a 76 micron pixel pitch, which is quite small for this size detector. But typically they range from 70 something micron all the way to 200 micron, are quite common in NDT. Quick comparison. I won't read everything on this slide, but some of the important things, obviously imaging plates are flexible, they're lightweight, you can cut them, whereas DDA, it's a fixed size, and they do weigh a few kilos, and this is important, especially when you need to place it up high or in a difficult position. They are harder to position, DDAs. But for a given size, imaging plates can go down to around 30 micron spatial resolution. And for DDA, it depends on the detector type. We have small detectors which can do really high resolution, but the bigger, more commonly used DDAs, usually we're talking about 80, 100 micron spatial resolution. So if you're doing really fine aerospace or space inspection, CR might be a better choice if you really need the maximum spatial resolution. Signal to noise ratio or contrast, as I mentioned before. DDA is actually better here than CR, and there's a few reasons for that, which I will talk about soon. And they're quicker to get the image. You nearly get the image live. In the long run, probably CR is, well, they both last a long time, the technologies. The scanner, we have scanners in the field which have been in operation for 10 years, more than 10 years. But it's the consumable imaging plate which usually needs to be replaced after around 1,000 scans because it does get scratches and damages from handling. Whereas the DDA, they are an electronic device, so they are susceptible to radiation damage. But if you use proper shielding, you know, they can last a long time as well. And I would say, you know, cost-wise, they are very similar in terms of how much you need to invest. But just to note, DDA, there's no consumables like CR. CR, you have the IP as a consumable item. Okay, now on to image quality. Already mentioned this, but imaging plates can go down to 30 micron, whereas DDA is fixed, usually based on the pixel size. And signal to noise, again, DDA wins in this respect. Yeah. So I just want to talk a bit about the practical part of using these devices. So both can be used with a range of different radiation sources. However, CR, I would say, is more flexible. You can use them, you know, with really high energy sources, cobalt isotopes, even Linacs. However, the dose time does increase. Imaging plates are more sensitive to lower energies. So as you use higher energy sources, you need to use higher sensitivity image plates, and you need to use longer doses typically. But on this point, DDA, when you're using higher energies, you need to shield them because they are an electronic device. So it does limit, it sometimes limits their application with in respect to the radiation source. Imaging plates or CR, you need to scan the imaging plate. This can take minutes sometimes, and whereas a DDA, you get the image almost live. Another nice point about CR is the scanner and the imaging plate, they're separate, right? So you can have multiple imaging plates and do multiple exposures in different bunkers. And then you can actually scan, depending on the image plate size, you can scan multiple imaging plates at once. So you can perhaps get a higher throughput with CR, because a DDA, if you have a single DDA, it's usually single DDA, single exposure, one at a time. So that could be a consideration, especially in a manufacturing, high throughput industry. Reshoots, DDAs, it's really becomes not an issue anymore, reshoots with DDA, because you get a live image. Whereas CR, if you do, you know, overexpose or underexpose, you do lose a few minutes because you need to re-expose and rescan. So DDA could be better there. Yeah, a lot of these things I've already mentioned. So of course, CR flexible, DDA not flexible, and not yet. There are, maybe this year is the first year we'll see some flexible DDAs. I can't really comment on what performance we can expect, but they are coming. But right now, all the DDAs on the market are rigid. Yeah, detector size, imaging plate you can cut, as I mentioned before, and they come, I think we've provided imaging plates up to 2 meters in length. So you can do that. DDA, it's a lot, if you're moving it around, it's a lot easier. It's a lot lighter usually. Our scanner, our HDCR scanner is fairly portable as well. It's about 17 kilos, but compared to DDA, it is, you know, there is more weight to carry. And there are consumables with CR, none with DDA. And CR actually doesn't require any calibration, or device or scanner calibration, whereas a DDA, you need to do periodic calibration. Bad pixel you should do every few months, gain more frequently, offset nearly daily. So DDA does require a bit more effort. for calibration. But there's very little maintenance. There's actually little maintenance for both, I would say. Our CR every few years maybe needs some light mechanical maintenance, but generally the maintenance effort is quite low for both technologies. And lifetime, this is something I mentioned before, so I won't mention again. Okay, obviously a DDA is a lot better in an automated setting, so you don't need to position an imaging plate and manually pull out the imaging plate to scan. You can just keep a DDA in place in a cabinet and do automated inspection, perhaps with a manipulator or some sort of robotic system to move or position the part. So DDA is a lot better for the automation industries, and also for live inspection of moving parts. DDA, you can't do it with CR, unfortunately, but with DDA you get a live image and you can do it. There are DDAs on the market, dynamic panels they're called, and they can do 20, sometimes 30 frames per second. So in terms of using them in the field, DDA, there are a lot of considerations. You need a connection. Typically you need a live connection to the DDA, so you need either an Ethernet cable or you need wireless connectivity to the DDA, and this can sometimes be difficult, especially if the DDA is in a hard to reach place. So it does sometimes require extra effort, whereas an imaging plate, it's lightweight, you can put anywhere, doesn't need power, doesn't need a cable or anything like that. You can put it nearly anywhere. And I would say the workflow compared to film, they're both pretty similar. With DDA, you do need to learn about the calibration, why we calibrate, how you calibrate. There's a little bit of a learning curve with DDA. I would say CR is an easier transition from film. And we do also have some ways to check device performance. And with CR, we have a CR Phantom, which is a test piece with many different kind of IQIs on it. And there are similar things for DDA. They're a bit less common, but something to be aware of. Okay, so the next section just kind of talks about a few industry applications and what kind of technology we would suggest for each application. I won't go through every line, so I'll just go probably over the more important applications. So let's have a look. Okay, oil and gas. So this is a very popular application for DDA, actually, corrosion under insulation. So corrosion under insulation doesn't need very high spatial resolution. You can use a flat, rigid detector. So DDA is quite good for this. You can get an image quite quickly. However, there are no intrinsically safe DDAs on the market. So if you're doing this in a gas refinery or something like that, it might be difficult to use DDA. You might not be allowed to use DDA. So in that case, CR could be better. CR could be easier to position in that respect. Pipe welds, big diameter, CR could be better in this case if you have a very large imaging plate. Small diameter pipe welds, DDA, if it's a 6-inch, 8-inch pipe, DDA could be suitable for this. You can get the image quite quickly. But this also depends on what basic spatial resolution you need. So if we're looking at the ISO 17636-2 standard, you need a certain spatial resolution, and sometimes DDA, you need to make sure your DDA can satisfy those requirements. And this point down here where we say weld thin material, that the reason we may recommend CR in this case is because it's just not possible to meet, for example, Class B ISO standards with DDA. So you may have to switch to CR, which can give you higher resolution. But for a thicker material where you don't need the higher SRB, DDA could be better because you can get the higher quality SNR images with DDA. So a lot of it is about SRB, especially for weld inspection. So it's important to choose your detector, your technology, after looking at what the standard requires you to do. Yeah, so this is a bit about aerospace here. Again, thin materials, we would say CR, but if it's a really small pipe welding, we do have high resolution, really small DDA panels, which may be suitable here. But back onto the topic of castings, I would say DDA, not only for its SNR capability, but its time to image might be good for casting applications, because a lot of the time throughput is very critical for casting inspection. So DDA can give you that faster time to image. I'm not going to go through every point here. But let's look at one in a bit more detail. So weld inspection, it's one of the more popular applications for digital radiography. The international standard is 17636-2. -1 is for film, -2 is for digital radiography. So this standard's really nice. It tells you, the techniques and what you need to do to get consistent high quality images with CR or DDA. So it tells you a lot about what spatial resolution you need, your minimum source to film distances. It gives you recommendations on energy levels depending on the thickness or the type of material. Tells you what kind of contrast IQI wire you need to see. So it's a very comprehensive standard and really tells you everything you need to know to do weld inspection with digital radiography. And one of the more important requirements is SRB, and this is the Class B table, the strictest requirement. And you'll see that when you have thin materials, you really need high spatial resolution. So this is 40 micron. And if we look at some of our products, so our scanner can do actually down to 30, which exceeds the 40 ISO standard. Whereas a panel, typically, if I look at all the panels on the market today, typically they can go down to say 63 micron. There are some things in the standard which allows you to compensate for lack of spatial resolution, but you can kind of say maybe down to 63 micron, so down to 4 millimeters of penetrated thickness. So you do need to look at this and choose the device or the technology appropriately. Now, if we look at manufacturing and how these two technologies could be suitable, obviously real-time imaging, DDA is the only option. You can get live image, high frame rate. Special heat exchangers where it may be difficult to put in a panel, CR is obviously a lot easier. You can cut the IP, you can have special shapes. It's a lot easier to use. Long welds, CR could be better here. We have customers using up to 1.5 or 2 meter long imaging plates to do these really long weld seams. Yeah, and I think a lot of this I've already mentioned. Thick parts, DDA could be better, thin parts, CR, because of its SRB capability. Foreign object detection doesn't need high spatial resolution, so DDA could be better here. So you really need to really look at your application and choose appropriately. A bit of a niche industry for us, but we do have customers doing this. Sometimes DDA, you just can't put a DDA where you want it if you're looking at certain types of artwork. So CR is very common in the art industry. It's due to its, you can bend it, and it's very thin and easy to position. So bit of a comparison, just to give you an idea of what you can expect between CR and DDA images. This is the same weld plate. I don't have the exposure times on here or the frame times, but this is just typically what you can expect. So on the left here, you can see we're achieving 63 micron SRB, whereas with a DDA, you can expect 100 micron. However, the big difference is the SNR is a lot better with DDA, and I'll talk about why. So there are a few reasons. The first reason is it's very easy to average images together. And when you average images together, the noise reduces. The other reason is you can calibrate a DDA, and you can practically remove a lot of the structural noise in the sensor. You can't do this with an imaging plate. You can't calibrate the grains, and because the grains are different, right? Different sizes, different distribution in the imaging plate. Unfortunately, we can't calibrate those variations out. And that's one of the reasons why SNR is a lot better in DDA. But the pixels are a lot bigger in the DDA panel, so you can't really match the resolution, spatial resolution you can get with CR. If we zoom in a bit, it's a different image actually, but you can see the CR image is a lot sharper if you compare these two, the DDAs on the right, CR on the left. However, it's a bit grainier, and this is the lower SNR, this graininess. But you can see there's more pixels inside of this void due to the higher resolution. However, it is a bit more grainy. Yep. So if you look at the DDA, it's a lot more uniform, and SNR is a lot better. But this, if it's a really fine defect you're trying to find, the DDA could miss it. So it's an important consideration. What size defect do you need to see? Another similar image actually. So I probably won't explain this, but it's similar to the previous slide. This looks a bit sharper, a lot more pixels inside the void, whereas this is a bit blurry, but not as grainy due to the higher SNR. So this I mentioned just before, one of the reasons we get the really nice images with DDA is because of the averaging. We can average them together. And this is an example, single image, looks a bit noisy, but if you average 10 frames together, noise significantly reduces, as you can see here. It's a bit of a zoomed in shot. We can now see these holes quite clearly, because if you have too much noise, you will miss some of these defects. This is just showing the pixel line profile, so it's very pronounced, the holes now. Whereas here, I mean, visibly I can kind of see them, but if you look at the line profile, it's very, very hard to see. Again, this is a similar thing, averaging. This is IQI, and just showing the effects of averaging. We get the sharper line profile here, and the image looks a lot nicer after we average. So very easy to do with DDA, and it's definitely, yeah, I recommend using averaging when you use, especially with isotopes. This is an interesting one. Homogeneity. CR is a lot more homogeneous in this example. And what does that mean? The pixel values are a lot more uniform here. And this, depending on how good your calibration is, this might not be the case. So I wouldn't take this slide. This can happen, but if you have a good gain calibration, you should see a similar kind of homogeneous behavior in a DDA as well. So getting near the end, I've said this a lot of times during the presentation, but you need to just think about your application and choose appropriately, because both technologies have strengths and weaknesses. One is, like, DDAs are not replacing CR. They both do different things and have their different strengths and weaknesses. So I would recommend, if you want to get into digital radiography, would be to get in touch with a digital radiography supplier like ourselves, and we can give you a good recommendation on what could work for you. And we do offer, as I mentioned at the start of the presentation, we do offer everything you need to do digital radiography, so including a cloud solution as well. So do get in contact with us if this is something you're looking to do. And we've reached the end, and I'm not sure if there's questions, but if you do think of questions later on, you can always email me and ask me directly. But there is a Q&A section in this webinar, and if you do have a question, feel free to ask now. Otherwise, I'll wait a minute or so. Otherwise, thank you all for attending. And again, yes, if you have any general questions about digital radiography, I'm always happy to answer them.